Assalamualaikum warahmatullah. Friends, this video lecture is about balancing equations. We are already done with making them, but not in this video. I'll be telling you this on another video. Well, before we can start the balancing equation, I just want you all to recognize few of the elements of the compounds or the compound formula through which you can actually identify the number of atoms in the formula. Like for example, you might have seen some certain numbers in any kind of equation with the formula as well. Like as if we write CO2, that means there are two oxygen atoms with one carbon atoms combined together in the single unit of CO2. That is what we call a formula or the molecule. At the same time, the number 2 that is written with H2O in this formula represents two hydrogen atoms connected with one oxygen, obviously. Another example is as if we write H3 4. Another molecule that is containing three hydrogen atoms, one phosphorus, and four oxygen atoms. So this is how we just consider the number of atoms taken out from the formula. But you need to be very sure about which element is written with what number. Like for example, this hydrogen is written with 3. That indicates the molecule contains three hydrogen atoms. This 3, which is basically in the subscript, right? This is the identity of the compound. During the balancing, we can never change this kind of subscript numbers, right? For example, you're short of one oxygen that is being transferred from reactant side to the product one, and you just need to put n number with CO, so you cannot make it CO3, right? So anywhere in the world you cannot find the carbon dioxide as a carbon trioxide. So this is not the identity of a compound. You're just violating some rules. So you need to be very careful about writing the numbers in the subscript, which is already written in this case because we are done with the equation method. So balancing does not require you to change these kind of numbers, which are actually in the subscript. So anything that is written in the subscript indicates a quantity, but you can never change it. You can just play with it. You can just have it multiply with different numbers to get the total sum of your choice. Fine. Then let's just proceed with another kind of number that is written with the CO3. Now this 3, if you can just check it out, this is basically connected with the whole unit. So we can say that this molecule contains three carbon atoms, and then the quantity 3 is multiplied by this 3. That makes it 3 into 3, 9 oxygen atoms in the single unit of CO3. That does not exist exactly. And then again, another molecule that is CO2, if you just put 2 besides the CO2, that makes the 2 units of CO2. It indicates we have got 2 carbon atoms and plus 2 into 2 is 4 oxygen atoms at the same time. So the number that is put before any kind of formula of the element or compound, that is completely multiplied with each and individual subscript to get the total quantity of the atoms in the formula. Like as if we can write 3 with H3PO4, so we have got 9 hydrogen atoms because 3 multiplied by 3 makes it 9, and then 3 phosphorus atoms. The sign says P contains only one in the subscript. Since nothing is written over there, that means P contains one in the subscript. That makes it 3 into 1 phosphorus, 3 atoms. And then again, this 3 is multiplied with 4, makes it 12 oxygen atoms in the formula. So the numbers which are basically put or you can write them before the formula, those are called the coefficients. Technical grounds, the technical thing is about the moles. You can call it moles, but just to balance them, we just call them coefficients, and we can change those numbers. We can change this 3, we can change this 3, we can change this 2, and we can put any number, whatever we want, whatever the number you think is of your choice for the balance equation is, we can just put on 7. So that makes it 7 into 2, 14 hydrogen atoms along with 7 oxygen in the formula. So when these things actually define that you can actually change the numbers before the formula. Those are called the coefficients, right? Another thing is the number put into the subscript, which is called the identity of the molecule. You cannot never change it. Let's move on to the balancing thing. Like this, in case of aluminum reacts with oxygen to form Al2O3 in the very first equation, you can just see that we have got two aluminiums on the right side. How did we find the two aluminiums? We just considered this Al2, two aluminum atoms. So if we just consider, the formula contains two aluminum and three oxygens on the right. And since we just taking one aluminum on the left and one oxygen molecule on the left side. So what we need to do is first we need to figure out how many total number of oxygen aluminum atoms are there in the formula. Look at this point. This is Al2, indicating that we have got two Al on the right side. Uh, what we can say is two atoms on the right, but we do not have any two atoms on the left. We just have one atom on the left. How do we identify? Just because of the number written in the coefficients, right? So if there is no number written in the coefficients, just consider it one. So we have got two elements on the right side. Now, if we just consider how many oxygens do we have got three oxygens on the right and two on the left. Well, this is the very first principle if you're balancing any equation and it gets difficult sometimes. So what you need to do on the very first hand is you need to convert the odd numbers into even one by multiplying them with 2. Like for example, I cannot change this O3. Fine, it is basically the identity of the molecule. Al2, 3 is aluminum oxide. We cannot change the subscript numbers. But in case, if we just put 2 here along with this formula, that makes it 6 oxygen atoms, as we have already interpreted above, right? Remember this time. So we have got 6 oxygens in Al2O3 and 4 aluminums, because this 2 is multiplied with this 2 and this 2 is also multiplied with this 3. Makes it 6 oxygen, 4 aluminum. So the number that is given is converting the oxygen into the even numbers. So we have just actually solved this puzzled equation. 2 into 3 is 6 oxygen. So what we need to make on the left side is 6 oxygen. We have already given the two oxygen atoms. If we just multiply this O2 with 3, that means get 6 oxygen atoms on the left side. So we have got balanced. And then again, for 2 into 2, there are two aluminum atoms on the right side. If we just need to balance it, we just put 4 before the aluminum. This is how we balance it. So first you need to convert any kind of odd number into even by just multiplying it with 2 or any sort of number that makes it an even number. Look at the question number 2. C3H8 combines with O2 to form CO2 and H2O. Like in this case, we can start with any of the numbers, but the elements are balanced at the end. What does it mean? This one is a compound, this one is a compound, this one is a compound. This is an element. Elements are balanced at very end of the equation. The reason is if you put any number along with any element in the equation, it's not going to bother, it's not going to disrupt any other numbers with the any other elements or compounds in the equation. So that means if I'm putting 16 with O2, 18 with O2, 9 with O2, it's not going to connect with the other elements. So, equation balancing principles. Well, starting with this point, that we need to balance the carbon first. Why? Because carbons have got three on the left side and right side contains only one compound, that is carbon, holding compound. So if we just put 3 here with CO2, we have actually balanced the number of carbon atoms. And then again, for hydrogen, what we can do is we have 8 hydrogen atoms on the left side, so and 2 hydrogen atoms on the right side. So 2 into what number makes it 8? Just put 4 beside that 2. That makes it 4 into 2 hydrogen, 8 hydrogen atoms, and plus 3 carbon on the left, on the right. So carbon and hydrogens are almost balanced, and right now we are searching for oxygen. Just look at this point. Uh, 3 into 2 is 6, right? So 6 oxygen in CO2. And 4 into 1 is 4. And 4 oxygens from H2O. That makes it 10 oxygen atoms. If you combine them, 6 oxygen plus 4 oxygen atoms, when you combine them, it makes it 10 oxygen atoms. Just to make 10 on the left side, we have got the number 2 already. So 2 is multiplied with 5 to make it 10. So this is how we just balance it. Another equation is kind of, a different equation. This is equation number 2. Okay, now the first thing is about equation number 3. It's not a simple equation. If you're taking the atoms to get them balanced, You just need to calculate them. You can do it, but it takes time. You need to figure out how many oxygen, nitrogen, if I can see a sodium element, aluminum are combined in what ratio, and finally we need to put some numbers which are actually going to disturb the others as well. So for these kind of equations, first you need to figure out whether it's just a combination of the elements to form a formula, or it's basically the ion exchange reactions. The ion exchange reactions appear and they look like this one. Like for example, the sodium was actually initially connected with OH, and then it gets connected with the NO3. Look on the right. So this is called the ion equation. And at the same time, aluminum was initially connected with this NO3 unit and finally gets connected with this OH. Look on the right. So these are basically the ion exchange reactions. So I would prefer, if you guys are actually calculating the number of atoms, you should go for the combination of atoms to get it balanced. How? The point is how. Well, just look at this point. We have got NO3 units. These are called the nitrate units. So far, if you have any idea about them, NO3 units are nitrate units which are actually present on the left and on the right side as well. Different quantities are given. On the left side, we have got 3 nitrate units. And on the right side, we have just only 1 nitrate unit because nothing is given above the brackets with the NO3 unit. So if we just consider that we have got 2 nitrate on the right side, this would have been a bracket along with the 2 in the subscript. Like what I'm telling you is this should have been like this one. So we have got 2 nitrates. So since we are not writing any kind of bracket along with any kind of number in the subscript, that means we just have only one nitrate ion. Just look at this point. 3 units initially, 1 unit finally. If we just put 3 besides any NO3, that makes it 3 nitrate units at the same time, along with 3 sodium atoms at the same time. So rather than balancing the atoms, we are balancing the number of ions. These are basically called the ion balancing. So we have got balanced NO3 units. So we've got 3 NO3 units on the right and then the left also. Well, about the hydroxide units, which are actually given in OH. So for this OH unit, any OH contains only one OH unit. If you can just check it out again on the right side, these are basically the 3 units given. So what do we consider is we need the 3 units to balance the 3 OH on the right side. So if we just put this number 3 before sodium hydroxide, that makes it providing 3 OH units, which are consumed to form aluminum hydroxide on the right side. So the 3 units on the right are given from the 3 units on the left. Now just look at this point. If we can just consider how many sodium we have, the 3 units. And at the same time, on the right side, we have actually balanced it initially, unintentionally, that was 3 sodium for the nitrates. So we have got balanced the sodium, we have got balanced the OH units, 3 on the both sides, and then NO3 on both sides. And now just look at this point. Let's stop it. Well, the last thing is about the aluminum. Just look at it. Al, one Al atom, right? And on the right, another one Al atom. So Al is basically balanced by default. So if you're just following this principle, it actually saves your time and plus your skills as well, because you need to figure out how does it work. And you need to multiply many numbers together just to get them total on the right and on the left. So it saves time. At the same time, if you can just check out equation number 4, that is KNO3 forming KNO2 and O2. It's not about ion exchange. It's about the decomposition reaction or a formation reaction or something else can be. So what we can do is balance the odd numbers first, or convert them into the even one. Like for example, if we just look out the quantity of oxygen in right and left side, we have got 2 oxygen plus 2 oxygen. That makes it around 4 oxygens on the right side. So it's completely fine on the right. Just look at the left side. It says KNO3. KNO3 means there are 3 oxygen atoms. So we need to convert this 3 into a number that belongs to an even category. So we just put 2 before KNO3 as a coefficient. The reason is it makes 2 potassium, it makes 2 nitrates, but it makes 6 oxygen atoms. So we have made the 3 oxygen into 6 oxygen atoms. So the conversion is already taken place. Now you have got 6 oxygen on the left side and some 4 oxygen on the right side. Now look at this point. We have got balanced night oxygen, I guess so, but K, the potassium and nitrogen are basically 2 on the left. If we can just put this number 2, sorry, no, not 4, 2, KNO2. That makes it 2 potassium on the right, 2 on the left, 2 nitrogen on the left, and 2 on the right. So we have got just balanced them. Then again, for oxygen, we need to work out. Like for example, 2 into 2 makes it 4. 4 plus 2 makes it 6. So we don't need to put any number to make 6 oxygen on the right. We have already done it. I'm again telling you that this 2 is multiplied with this one to make it 4 oxygen on this formula. And along with these 4 oxygens, we have got 2 extra oxygens on the right side, which is O2. So 4 plus 2 makes it 8. Sorry, 6. Right. So this equation is also balanced. Now just look at this equation number 5. O2 plus CS2 forms CO2 and SO2. We just need to put some numbers before the compounds instead of the elements because elements are balanced at the end. Look at this point. We have got carbon already balanced. Carbon, carbon, balanced both sides. Now what about this sulfur? Sulfur is given 2. We cannot change this number as we have talked earlier about this that this is basically the identity of the compound, so we cannot change it. What we can do to balance this sulfur is just put 2 besides SO2. And this SO2 makes it basically 2 sulfur on the right and 2 on the left. So we have actually balanced it. Now look at this point. Carbon and sulfur are completely balanced. Now look for the oxygen. Oxygen, for this CO2 units, we have got 2 oxygen. For this SO2 unit, we have got 4 oxygen atoms because 2 multiplied by 2 is 4. So 4 plus 2 is 6. What we can do is put anything besides 4 2 makes it 6. So 6 oxygen on the left side and 6 on the right side. This is how we have balancing equations. Now look at this equation again. KClO3 seems somewhat similar with the equation number 4, that is KNO3. So we started KNO3 balancing along with the conversion of you can say the odd numbers into even, then multiply the other things with the other numbers to get it balanced. At the same time, the strategy remains same. So we need to put some number before the KClO3 because it contains the 3 oxygen atoms. We need to balance them first or make them convert it to some even number. So putting 2 besides it makes it 6 oxygen on the left side. Since we are not just going to balance oxygen because elements are balanced at the end. So we have got 2K on the left and 1K on the right. So if we just put this 2, we mix it 2K on the left and right, 2Cl on the left and right. So we have got balanced the potassium and chloride atoms, chlorine atoms on both sides. Now just work out for the oxygen atoms. 6 oxygen on the left side. Remember, this 2 multiplied by 3 to give it 6 oxygen atoms on the left. 6 on the left. To make it 6 on the right, we need to put 3 besides O2. That makes it 6. Hope this was completely understood. Equation number 7.